Okay, can everybody see my screen? I've just shared it. Yeah, can everyone see my screen?
Yes, I can see it.
Okay, so let's get on with the questions itself. For any distribution, the standard deviation can be easily estimated by what do you think? I mean, don't look at what I've marked. Just what do you think? Because this comes only if you have some experience with data. So, do you think standard deviation can be estimated from the mean? What does the mean tell you? Any Does it tell you anything about the distribution of the data itself? Like how widespread, how um, narrowly or widely the data is spread? Does the mean tell you anything about that? No, right? All these are point estimates actually. Mean, median, and mode are just point estimates. They are characteristics of the distribution, but they don't tell you anything about how widely the distribution is spread. Range is one thing that tells you that. It tells you the lower and the upper limit of the data. Okay, so it tells you what the maximum value of the given data is and what the minimum value is. So that tells you how the data is spread to some extent. Now, a thumb rule that people use in statistics is that, give me 1 minute. Yeah, a thumb rule that people use is standard deviation is nothing but range divided by 4. Okay, so that's some thumb rule. So yeah, you can use the range to get some approximate idea of what the standard deviation and that is this. This is not, again, just to make it clear, it's not mathematically correct. Okay, these are thumb rules. Uh, if you do a lot of plotting of data and things, you see that the standard deviation is around this value, the range divided by 4. For example, for a normal distribution, you have what 99% of your data is covered by 3 standard deviations, right? So that's 99% of your data. That's close to, so that 99% of data is close to the range. It's not exactly the range, a little less than that range. And that divided by 3 gives you standard deviation. You know this, right? 3 into sigma. Sigma is standard deviation, so right. This is 99% of your data, which is very close to this approximation. So if you bring this down by 3, it's divided by a factor of 3, but it's not entire data. Your entire data by 4 is pretty close to your standard deviation. So yeah, you can use the range to get some ballpark figure of your standard deviation, which was the answer to the first question. Is everyone okay with that? Please let me know if you have a doubt. Yeah, I'm going to take that silence. I don't know what I should take the silence as. Are people okay with this answer that you can estimate the range using standard deviation using this formula?
Yes.
Okay, it's a thumb rule, it's not exact. Okay, next question. Okay, this now I think all of the other questions are to do with hypothesis testing. So which of the following is an alternate hypothesis for a two-tailed test? Okay, so what it means is which of these signifies a two-tailed test? Okay, which of these do you think? What is a two-tailed test anyway? Can someone just briefly explain? Anyone? What a two-tailed test is? So a two-tailed test is nothing but to check whether a given hypothesis, say a null hypothesis, is sorry, a given hypothesis is equal to the null or not. For example, the number 10 here is a null hypothesis. For example, to give you an example, it could be like, okay, the height of all trees is 10 meters in a given area. That could be your null hypothesis. Now you go and test whether you go and measure all the trees in that area, and you want to see whether all your measurements are different from 10 meters or not, whether your sample of measurements that you have done, do they differ from the null hypothesis. Okay, whether the mean of all the measurements you have made is different from the null hypothesis. To do that, you use a two-tailed test, which is basically you try and ask the question, okay, I've sampled so many trees in this area, the mean of this is not going to be equal to 10. So that is a two-tailed hypothesis. As opposed to that, if I say, okay, the mean of all the trees I measured is greater than 10 meters, something like that, then it would be a one-tailed hypothesis. So when you have just greater than or lesser than, it becomes a two-tailed hypothesis. But when you have like not equal to, that kind of symbol, that becomes a two-tailed hypothesis. And if you have greater than or lesser than symbols, it becomes a one-tailed hypothesis. For example, this here, HA, given that the null hypo the mean is less than 10 meters of the hypothesis that you want to test, this is a one-tailed hypothesis, whereas this is a two-tailed. Okay, is that clear with one-tailed and two-tailed what hypothesis, what they mean, what you mean by one-tailed and two-tailed test? Two-tailed test basically tell you, ask a question whether the mean of certain measurements you make is equal or not to some null hypothesis. Whereas one-tailed tests tell you whether the mean of certain measurements you make is greater than or lesser than some null hypothesis. Okay, that's the only difference between two-tailed and one-tailed test. So the answer for that question is your null hypothesis is not equal to 10 is an example of a two-tailed hypothesis testing. Okay. Third question is, for a test, the null hypothesis is 10. Okay, the mean is 10, and the alternate hypothesis, that is H subscript A, HA, is mu less than 10. So what kind of test is it? Is this a one-tailed test or a two-tailed test? Just by looking at the information here. Can someone tell me?
It's a one-tailed test.
One-tailed test.
One tail.
Yes, it's a one-tailed test. Now, given you want to test this one-tailed hypothesis, you're at alpha is 0.05. You must be clear of what alpha is. It is the significance level. So hypothesis can be tested at various significance levels. The widely accepted norm is that alpha should be 0.05, but you can have 0.1 also. For some cases you have 0.01. For example, like vaccines, working of, say, for example, COVID vaccine and all, your alpha should be less than should be actually 0.01, because it's a very important hypothesis you're making. It deals with human life, so you should be very sure of your test. Okay. Now, given this hypothesis and alpha level, you're given a z statistic of minus 1.75, and you need to know, and you need to answer whether the conclusion, and you need to conclude whether you want to accept the null hypothesis, reject the null hypothesis, data is inconclusive, and alpha must be lower or whatever. What do you think the answer is? Anyone? Okay, I'll do this for you because it requires slightly more information. What information you need is, you need for each alpha value you need corresponding z values. Okay, and if you look online, if I just type alpha values for z statistic one tailed test, okay, maybe, yeah, So what you get is for each alpha value you get a value, for each z value alpha value you get a z value. This is from a table that has been standardized. You need to look up such tables, okay? Usually they are, yeah, you can find them on the net or anywhere. So for alpha value 0 of 0.05 you need a value whose magnitude is greater than 1.645, okay? So it should be greater than this. Now if you see the question, the given z value is 1.75, so the magnitude of that, it's actually minus 1.75, but the magnitude of that is greater than 1.645, which is the level of, which is the required z statistic for an alpha of 0.05. Okay, the negative sign signifies that you're doing a one tail test, and on in which direction? In the left direction when mu is less than 10. Okay, that is what the negative sign signifies. So given this value, what do you think the answer is? So the z statistic is that you require is minus 1.645, and this is minus 1.75. The magnitude of this is greater than the required z statistic. Okay, so what do you think should happen? If should you accept the null hypothesis or reject the null hypothesis? So if you see this table, as you go lower and lower for smaller alpha values, your z statistic keeps increasing. The magnitude keeps increasing. Okay, likewise, so this is a left tail hypothesis. If you see, which is the relevant to the question, it goes from minus 1.2, keeps going till minus 3.79. So the magnitude is increasing. Obviously the actual value is decreasing, but as the alpha value decreases, the magnitude of your z value increases. So what it tells you is the high, if your z value is higher than 1.645, the magnitude, then you should reject the null hypothesis. Okay, which basically means you your measurements that you have made with a mean of you're testing this hypothesis, right? That HA is where the mu is less than 10. This hypothesis is true. So you reject the null hypothesis. What is the null hypothesis? The mean is equal to 10. But if you have this z value, which is whose magnitude is greater than 1.645, you reject the null hypothesis. Okay. So this is the answer. Is everyone okay with this? Maybe I'll just paste this link where you can look up tables for certain alpha values. For example, here alpha zero point 0.1, the value is minus 1.282. For 0.05, it's minus 1.6, something like that. Okay. Uh, yeah, I've pasted the link for that. But let me know, okay? Is everyone okay with the explanation as to how we got to this answer where we rejected the null hypothesis? Yeah, is that okay? Does anyone have doubts?
Yes.
Please ask. Anyone with doubts? Okay, we'll move on to the next question. So the next question is that a t-test is done where your null hypothesis is 81, the mean is 81, and the mean of your sample is 84.1. The standard deviation is 3.1, and the number of samples, the sample size is 25. What is the value of the standard variable? By standard variable, they mean the z statistic. So how you calculate that is you do a mu absolute value of the null hypothesis minus the mean that you obtain from your sample divided by the standard deviation by square root of your sample size. Okay, if you do that, it's straightforward. It's this formula. If you substitute the values, that is mean of the mean hypothesis is 81.6, your sample mean is 84.2, the given standard deviation is 3.1, and your square root of your sample size, which is 25. If you compute that, you get this answer. That's the answer. So it's basic substitution that you need to do and figure out the answer. That's simple. The next question is, okay, do you all know about type 1 and type 2 errors? There was a hilarious example long time back. Let's see if it still exists. Yeah. So can all of you see my screen? Hello?
Yes, sir, we can see.
Yes, sir.
Okay, great. So I'll just point you to this image. So type 1 error is when you get a false positive. Okay, what is a false positive? Is when there is, for example, this man here cannot be pregnant, right? But you detect him as to being pregnant. That's a false positive. Okay. So the case where you reject the null hypothesis is what? He's not pregnant. That's the null hypothesis. And the conclusion you're making is you're pregnant. So you're rejecting the null hypothesis falsely. Okay. So that's a type 1 error where you reject the null hypothesis in a false manner, or more easily, it's called a false positive. Okay. And the next, and type 2 error is when the actual hypothesis, when the hypothesis you're testing is actually true. That is, she is pregnant. Okay, that is true. And the null hypothesis is you're not pregnant. And you falsely accept the null hypothesis. So that is a false negative. When you falsely accept the null hypothesis, it's a false negative. And when you falsely reject the null hypothesis, it's a false positive. So that the false positive comes under a type 1 error, and the false negative comes under the type 2 error. Is that okay? Explanation? If that's okay, then you should be able to answer this. Type 1 error occurs when? So when does a false positive occur? Anyone? Did everyone understand what a false positive is? You can make a wild guess, it's okay. We're all learning. Yeah? Does anyone want to have a go at this? Can everybody hear me? Because it's raining outside, the communication might just go.
Yeah, it's H naught is true and H naught is rejected.
Yes, that's the answer. Yeah. So basically, what is happening is that uh, your null hypothesis is actually true, but you reject the null hypothesis falsely, is when you get a false positive, which is a type 1 error. Okay, that's the correct answer. Please, so the best way I remember is through this example, which is why I still remember it. But please do remember what a type 1 error and a type 2 error. Type 1 is when you get a false positive. For example, it's like someone does not have COVID, but he's diagnosed as having COVID. That's a false positive. Okay, and the false negative is someone actually has COVID, and you say, okay, you don't have COVID. So that's a false negative. Okay. Okay, which of these is a right tail test? We have done this earlier. Quickly, anyone?
B. B
Yes,
is right tail
B is
test.
right tail. When you check for whether your sample mean is greater than the hypothetical mean, it's a right tail test. That's great. Next question, which of the following errors cannot be controlled? So we have type 1 and type 2 errors. So this is your type 1 and type 2 error. Which of these cannot be controlled, or can either of them be controlled? Anyone?
Type 2 cannot be controlled by the researcher or the statistician.
Yes.
Type 2 is not
Yeah,
controllable.
Yes.
type 2
Yeah.
cannot be controlled.
How do you control type 1?
By increasing the sample size
That is one way.
or
The other
study
way
design.
is by reducing your alpha significance. You have this alpha value, right? if you reduce that, if you increase that, sorry, if you increase that to say 0.1 or zero point 0.2, sorry, if you decrease that, if you decrease your alpha level to smaller values, you reduce the chance of getting a type 1 error. But type 2, you cannot. Okay. Then a pair t-test consists of n pairs of observations. What is the number of degrees of freedom of the test? What do you mean by number of degrees of freedom? Number of degrees of freedom basically mean that, okay, if I tell you the IDs of say some X number of individuals, you should be able to tell me the ID of the remaining X individuals. Yeah. Now, when can that happen in a t-test? It can happen only when I give you the IDs like the values of n minus 1. So suppose you have a data set and I say n minus 1 distributions are these. I label them as 1, 2, 3, 4, 5, 6, 7, 9, 10. And there are 20 observations. I tell you, okay, about the 19 observations, you can easily figure out from where the 20th distribution is coming from, right? From which person or something. Suppose I have 20 patients and I give you the names of 19 patients from where I have taken measurements. You will obviously know from where the 20th patient's reading is coming from, because you know the 19 other names of the 19 other patients. So that is nothing but degrees of freedom. So if you have n pairs of observations, for example, if I measure each pair like 20 pairs, if I tell you the IDs of 19 pairs, you will immediately be able to tell me from where the last pair of observations came from. Okay, so the number of pairs I need to specify for you to figure out, okay, what are the remaining, where the remaining measurements are coming from, is nothing but your degrees of freedom. So for example, if I just substitute this n as a 20 pairs of observations, if I tell you about 19 pairs, you will be able to tell me the 20th pair. So 19 is basically 20 minus 1, so n minus 1. Okay, is that okay with everyone? So it's basically the minimum information you need to tell me about the remaining data set from where those observations are coming from. Is that okay? Was
Yeah.
okay, great. Let me try and ask you this question. Uh, uh, give me, I can't think of any easy example on the top of my head, but yeah, just read up
Sir,
on
may I frame one?
it. Yeah.
Sir, may I frame one?
Okay. Yeah. Tell me.
Here we are 19% participating in this program.
Okay.
I am willing to gift my own valuable pen to someone
Okay.
of these fellows.
Okay.
Obviously, I cannot do it to myself, but I have to do to someone of the remaining 18% out
Yes.
of these.
Yes.
So 19 minus 1 is 18. So
Yeah.
the
So you
1
know
is
yourself.
already taken up.
Yes.
So the
Yes.
probability is to give to the remaining persons.
Yes.
1 is already taken up. That's why it is n minus 1.
Yes. That is another way of looking at it. So if you know the ID of one, no. So basically, the number of ambiguous IDs in a population. For example, like he said, he knows his identity, but he does not know anyone else's identity. Okay, that's n minus 1. So these are the number of ambiguous people in this group because he knows his name and does not know anyone else's name. That's another way of looking at degrees of freedom. Okay, great. That's nice. It was a nice analogous explanation. Okay, what will happen to beta if n sample size, if to beta, if your sample size increases? So for this, I'll just maybe just tell you what beta means. So beta is actually a parameter you use while figuring out the power of a test. Okay, and the power of a test is given by 1 minus beta. Okay, this is called the power. Let me just write this. Power of a test is 1 minus beta. Okay, now the higher your power is, it reduces the probability of making the type 2 error. Okay, okay, so basically this value will become higher if your sample size increases. Okay, now when will this value become higher? When b becomes smaller, right? And b can be made smaller by increasing sample size. So this entire value can become smaller when your sample size increases. There's a little complicated math to show that. I won't go there now. But this value 1 minus beta becomes greater when your sample size increases. Okay, so that means this beta is getting smaller as your sample size increases, which basically comes to the answer of the question, that is, when your sample size increases, your beta decreases and your overall power of your test increases, which basically reduces your type 2 error. Okay, and the last question is, how will the area of rejection region for a two-tail test compare to that of a one-tail test with the same significance level? What do you think the answer is? Anyone?
Remain the same.
Yes.
It will remain the same, sir.
Yes. So I think I've just borrowed it from your notes. What happens is, when you do a t-tail test, the significance value alpha, if it's 0.05, you divide it by 2. So it becomes 0.025 and 0.025 on either side. Whereas for a one-tail test, you just have that 0.05 significance level. The area under this, for example, this, if I shade this region here and this region here, that will be equal to the shaded region here. Okay, so the area remains same when you're doing a two-tail or a one-tail test at the same significance level. Okay, great. So that brings us to the end of this session, as in this assignment. Any questions from this or anything related to this? Anyone?
Sir,
Yes.
one thing can be highlighted in the degree of freedom.
Yeah.
Degree of freedom for unpaired t-test, it was n minus 1.
Yes.
Paired t-test, it was n minus 1.
Yeah.
But for unpaired t-test for between two groups, it will be 2n minus 1.
Yes.
That's why that option is given there.
Okay. Yeah.
This is
Yeah.
one thing to be highlighted.
So I think different tests have different degrees of freedom. Sometimes it becomes actually difficult to calculate your degrees of freedom for very complicated statistical tests. But the basic idea you need to have in mind is, degrees of freedom refer to the number of entities that have ambiguity. That is, you cannot assign an ID to it. For example, in a population of n individuals, you don't know, given n minus 1 names, you can figure out the last name in a class of say 20 students or n students. So that is the minimum amount of information you need. That is nothing but degrees of freedom. Okay. Yeah. Anything else?
So one more doubt I have.
Hmm?
One doubt I have.
Yeah. Yeah. Tell me.
So you were using the formula for Z test. I saw it in your slide that you used modulus for the formula.
Yeah.
So is it always positive, because the value which is in the mod, it's always positive, right?
Yeah.
So
Yeah.
yeah. So that's what I wanted to ask. That is that always positive?
No, no, actually,
Yeah.
I have used, so this Z statistics, I use the modulus just so that for a two-tail test, that is what is required. But when you're doing one-tailed, you don't have to use the modulus.
Okay. Got it.
Yeah,
Yeah.
because there you're actually worried about whether a value is greater than the hypothetical mean or lesser than. So there you don't have to use the modulus. But for a two-tailed, yeah, you have to.
Okay. Thank you,
Yeah,
sir. Thank you.
yeah. Anyone else?
Sir, I have a doubt in the second question. Which of the following is an alternate hypothesis? I didn't understand that again. How
Yeah.
we can assume mu to be not equal to 10?
So that is your alternate hypothesis, right? Okay, let me try and okay. You have a hypothesis, right? Any, like for example, if I go out and measure, say, the height of trees. Let's stick to trees in an area. Okay, you go and sample trees and you get a mean. Okay, now someone tells you that the standard measure of trees in this area is 10 meters only. Okay, someone has just told you that. Now you have measured all of this actually, and now you want to compare this to whatever the standard is. The standard thing is your null hypothesis. Whatever is prior knowledge or no knowledge is called a null hypothesis. For example, I can say that, say if you're comparing the heights of males and females in a population of humans, I can say the null hypothesis is height of males is equal to height of females. That's a null hypothesis. Here it's the null hypothesis is 10. 10 could be anything, say height of trees in an area. Okay. Your alternate hypothesis, which is HA, you have calculated some mean there. Okay. We say a mean is some 10.8 or 11.2. You want to test whether it's in a two-tail test, you test whether it's equal to 10 or not. Okay. That is what you test in a two-tail test of an alternate hypothesis. Whether the mean that you obtain by sampling is equal or not to a null hypothesis. That is your alternate hypothesis for a two-tail test. Is that okay?
Yeah. Yeah.
I mean, you can ask me to repeat or ask any doubts you have after my explanation. So this mean is what you have measured. Yeah, tell me.
Sir, I had a query regarding the question 7 and 9.
Oh, okay. But is that clear with question 2? Is that okay, the explanation? It was someone else. I do. Sorry, I don't.
Yes. Yeah, it was clear.
Great. Okay. Number 7 is a petty. Yeah.
Sir, yes,
Yeah.
sir. Like we can't control type 2 error, no, sir.
Yeah.
Sir, regarding the question 9, like beta is more or less related with type 2 error.
Yes.
It's this. So, like if there is any relation between sample size
No.
with regard to beta,
There is no mathematical relation actually. It's heuristic. So whereas your type 1 error can be controlled, when I said that it can be mathematically controlled by increasing your alpha. Okay. But given a set of observations, you can't artificially increase beta like after you have made all the measurements, so you can't control for that. The only way you can do it is, yeah, you can increase sample sizes to a certain extent. You can control your power, which is your type 2 thing.
Sir, it means for 7, like is the answer is like type 2 error we have mentioned as it can't be controlled.
Yeah.
So it's contradicting the 9th question answer. Like
Yeah.
the sample
I
size
get what
plays
you're
a
asking.
role. Yes, sir.
So what this question means is that, okay, is there some mathematical way in which you can control these errors? Okay.
Okay, sir.
So that can be done simply by increasing your alpha. You can just decrease your type 1 and you don't have to do anything with your data. Yeah. But whereas here you are given some data. Okay. It's not guaranteed that if you increase your sample size, your power will increase. It's not guaranteed. It does increase your power, but how it does or whether it does, is again questionable. That depends on the standard deviation and it depends on your data itself. There's no mathematical way for you to do it.
Sir, it means it remains same or increases exponentially or just
It just
increases,
increases.
sir?
It just increases. But I get your question. Yeah, there is slight ambiguity in how the seventh question is framed. It's actually cannot be controlled in a mathematical manner. Okay, like just through equation. But here, this is more heuristic. You can increase. So the general notion is both type 1 and type 2 errors can be decreased when you increase sample size. Okay, but it's not guaranteed. It's not guaranteed that that will happen. Yeah.
Thank you, sir.
Okay. Great. Anyone else?
Sir, I have another doubt.
Hmm?
Can you confirm the answer for the fourth question? I just wanted to make sure my calculation is okay.
4.032.
Okay. Okay.
So it's basically just mu1 minus the sample mean by sigma by.
Yeah, yeah.
Yeah. Okay. Anyone else?
Yeah, sir. Hello.
Yes, tell me.
Yeah, actually, the power of beta will increase, but beta will decrease, right, with
Yes.
increase
Yeah,
in
beta
sample
will
size.
decrease. Yeah, beta will decrease your power. Oh,
So
sorry,
that
sorry. Yeah, yeah,
question
sorry.
answer is
Yeah,
decreases,
yes,
right?
decreases. Yeah, I just
Yes.
made an. Let me just check my
Yeah.
notes if I've made some error. So 1 by beta. Yeah, so B decreases.
Yes.
Yeah,
Yeah. Yeah. Thank you. Thank
yeah.
you.
Sorry.
And
Yeah, the power increases. Yeah, power of a test increases. Yeah.
sir, actually, I have you discussed the question number 10? I joined just now. Have
Yeah,
we discussed the
we
question
have,
number
we
10?
have, we have. So I'll just maybe repeat
Act.
it. Yeah. So
Yeah.
given an alpha value, how does the area of rejection in a two-tailed test compare with that of a one-tailed test? Okay. So for example, if you're given an alpha value of 0.05, how does the area for a two-tailed test compare with that of area of rejection of a two-tailed test compare with that of the one-tailed test? So this is a one-tailed test, this is a two-tailed test. So this is, so when you do for a two-tailed test, on each edge you divide your alpha by 2, 0.025 you get, for alpha is 0.05, and you check that rejection area is this, these on these edges, whereas here the alpha value is 0.05, so it's this area. Both these areas, if you add these two areas on this side and this side for a two-tailed test, it will be equal to the area on this side. So the area
So they will be same.
yeah, they remain same. Yeah, the area will remain same. Okay.
But their chosen is area will be
Oh
larger.
no, so actually don't see this. This
He is
is,
asking for the
Area
yeah,
will be same.
yeah, area will be the same. Don't look at what I've marked here. Okay, I marked, now I put
Okay.
it.
Okay.
I just have this thing, but the answers, so you can refer to the slides which I upload after everything, where there are correct answers. Where I don't put the option actually, I just try and give the explanation or the answer itself. Okay. For the explanations, you
Yeah.
can probably go to the video also sometimes.
Yes, sir. Sir, when you finish, I have a doubt regarding the assignment 6. So
Okay. Yeah.
can we
I
go
think,
to
yeah, we are
that?
done. Is everyone okay with assignment 7 for now? We can go back to 6 if everyone's done with 7. Is that okay with everyone? Please tell me if it's not okay and we can stay here a little longer.
it's okay, sir.
Is it okay from everyone?
Yes, sir.
Okay, great. So let's go to week 6 assignment. Yeah, tell me.
Yeah, actually, you told that which one is 60. Just please go down.
Yeah,
Yeah, the question number 5.
5.
In
Yeah,
the standard deviation, population is 60 and sample size is 25.
yeah,
You told that the answer will be 60.
yeah,
And in your note also it is there in 60, because you told
yeah,
that sample size is 25, very less, so it will not the sample standard deviation will not be much less than that. It will
yeah,
be just nearly about 60, right?
yeah.
But in the answer keys that we have got after submission,
Okay, yeah, I see
that
12
it's
is
telling
the.
that it is 12. So is it correct or not?
Okay. Uh,
because it has calculated 60 by root over of 25. That is 60 by 5. That is 12. So
Yeah,
that
but
in that way they have calculated. So, so which one is right? I'm just
no.
confused.
So I don't know what the logic behind doing 60 by 20, root of 25 is. I don't know what that. So
As because the sample standard deviation is a different thing and standard error is different thing.
yeah,
So standard error is that sigma by root n, the
yeah,
s by root n. That is
yeah,
standard error.
yeah,
But it is asking standard deviation.
yeah,
So I
yeah.
don't know
So the
whether I
answer is
should get
actually
marks because my marks have been cut, right?
okay. Okay, I will mail this to the people because I think it is wrong. Okay, why I'll tell you. If you do it from first principles, uh, it should be around 60. I'll tell you why. Okay, this is just going by logic. And I'll just mail these people.
Yes, sir. I do agree with you.
Just give me one moment. I don't know which is assignment 6. Okay, I think this is assignment 6. Let me check. Yeah. So why I tell you it's 60, close to 60 is uh, which question was
Question
it?
number 5, sir.
5. Okay. Now, this is how a sample's standard deviation is calculated. Okay, you have the sample mean, right? And
Yes.
each random variable, you calculate x minus each value of the random variable. You all these measurements that you have taken, you calculate x minus the mean, square it, sum it, and then divide by n minus 1 and take the square root of it. Okay, that's a
Yes.
sample standard deviation. The
Yes, sir.
population standard deviation is whatever data, so even the x remains the same here, all the data points minus the population mean. Usually population mean is very similar to the sample mean. Okay, usually. Okay, so you can take this
Yes.
and this x bar and mu to be similar, and then you sum over everything divided by n is your population size.
Okay.
Okay,
Yes. So it cannot be such less like 12, right?
yeah, it cannot be. So if you're, say, if my population itself was of 25 individuals, or
Yes, sir.
okay, if this is an assumption I'm making about the distance, I've measured all the samples in that. I've measured all the data points in that sample. So that's 25, and this will become 24 then. Okay, so it's not very different. So it's 60.
Yes, sir.
Sigma by root n is nothing but your
Standard error, sir.
standard error, which is different
Yeah.
actually. I don't know.
Yes, sir.
I'll just write to them. Yeah. But thanks
Sir,
for bringing
please.
it up. Thanks
Yeah,
for bringing
actually,
it up.
my marks have been cut, so I'm just
Okay.
worried about this.
Okay.
Yes,
I
sir.
will. I will tell them. And don't worry about marks. Yeah. But I will tell them. The important thing is to
Yeah, it will
understand.
reflect in the certificate, right, sir?
Yes. Yes. It will. It will. I
So,
will. I will write to
okay.
them. Yeah.
Okay,
Great.
sir. Thank you. Thank you so
Thank you so
much.
much. Okay. Let me know. So all these things, let me know in the next session whether they are clarified or not by next week. Okay. Yeah. Great.
Okay, sir.
Thanks. Anyone else with anything pertinent to the
Sir,
course? Yeah.
sir, regarding the last problem discussed, that population mean and sample mean,
Yeah.
I would like to have some different opinion.
Okay. Tell me.
As the sample size here is small, it is
Yeah.
n is 25 only.
Okay. This one. Yeah.
Sample size is small.
Yeah.
So population the mean will vary significantly from the sample mean.
No, but how will you make a mathematical reasoning for that? Sometimes n equals 25 is good enough if your population itself is very small. Say if I have a population of 30 individuals and I measure 25 individuals, then it's okay. It's high enough. So it's relative. So you have to give some mathematical reasoning to this. I don't know how, and 12 is, I don't know how that is correct. But if I'm
12 is
wrong,
not the probably not the answer, but it
yeah.
cannot be exactly 60
No, it's
also
not
cannot
exactly
be.
60. I didn't say it's exactly
12
60.
cannot be answered.
Yeah, it cannot be
It should be
answered.
close to 80, but it is close to 60, but not exactly
Yeah,
60.
that I agree with you. It's close to 60. It's not exactly 60.
Because standard error of mean here is 12.
Yeah.
12 is the standard error of mean in this case, as she said earlier, that it is the standard error of mean, what she was
Yeah.
telling. That is, 12 was the standard error of mean.
Yeah.
So from that, there must be a mathematical relation between the population mean and the sample mean.
Hmm.
Sample mean is significantly deviant from the population mean here. That's why.
Yeah, that we don't know actually, no?
But it is not 12. Definitely, it is not
It's not
12. It is
12. Yeah. Yeah.
standard error of mean.
It's a big standard error. I agree that.
Yes. Because the sample size is small. Again, the sample size is small. That's why the standard error of mean is large.
Yeah.
If the sample size could be bigger, if the denominator is larger,
Yeah.
then the product will be that. Then the result will be definitely less.
Yeah. Yeah.
It is due to small sample size.
Yes. Yeah, but I don't know where the. Yeah, I think we can bring this up. But it's not 12. I don't know. Sigma by root and that standard error of the mean and how that relates to standard deviation of the population is beyond me.
Here we cannot apply sigma by n, root
Yeah.
n. We
Yeah.
have to apply sigma by root over n minus 1.
Yeah. Yeah.
It
Not
is
sigma,
sample.
not sigma, but the actual sum of distributions.
Standard deviation of the population.
Yeah, see?
The mu.
Yeah, so you need to apply this formula. Which is, yeah, I'll just bring that up. Okay, great.
Okay, thank you, sir.
Okay, anything else? Okay, if that's nothing for now, I'll just take my leave and see you next week, same time. Okay. Thank you so much for
Okay,
attending
sir.
the
Thank
class.
you, sir.
Okay, great.
Thank you, sir. Thank you so much.
Yeah,
Thank you, sir.
thank you.